Hello everyone. Today we'll be discussing module 2 of basic electronics, that is on BJT and FET, that is on transistors. So basically there are two types of transistors, one is BJT and one more is FET. So in this particular module you will be studying the basics of both BJT as well as FET. So as I said, we have two types of transistors. One is BJT, bipolar junction transistor, and the other one is field effect transistor. So BJT, in BJT you will be studying about introduction, BJT voltages and currents, amplification, and different configurations of BJT, that is common base, common emitter and common collector configuration, and biasing of BJT. And in FET we have three types. One is JFET, junction field effect transistor, MOSFET, and in MOSFET we have two types, enhancement MOSFET and depletion MOSFET, and we'll be studying all the three types of MOSFETs, basic construction and working. Okay. So for this, the prescribed textbook says David Abel, Electronic Devices and Circuits by David Abel, Chapter 4, Chapter 5 and Chapter 9 you have to refer. So before we actually move on to BJT and FET, let us know about transistor. So you already have studied on in your PUC on transistors. So transistor is an electronic device which is made using three layers of semiconductor material that can act as an insulator and a conductor. It's a three-layer transistor, okay, which is also known as, most commonly we call it as bipolar junction transistor. The basic construction of transistor is, it's a three-layer 2p-n junction. In the first diagram you can make out it's a three-layer device, and in the second diagram you can make out here we have 2p-n junction. Between n and p, one p-n junction. Between p and n, one more p-n junction. So transistor is a three-layer 2p-n junction semiconductor device consisting of either 2n and one p-type layer, which is called as npn. This is npn. We have two n-type semiconductor material. Between that we have a p-type semiconductor material, or the other way is between two p-type semiconductor material we have a n-type layer. So that is a PNP transistor. So in BJT we have two types, one is NPN and one more is PNP transistor. So when you construct the transistor, transistor has three regions, namely emitter, base and collector. Okay, this is emitter and this is base and this is collector. Okay, emitter is usually denoted as E, base will be denoted as capital B and collector will be denoted as capital C. So the term bipolar reflects the fact that both holes and electrons contribute to the flow of electrons. That is the meaning of bipolar junction transistor. So types, as I said, you will be studying on BJT and FET, but we have UJT as one category of transistors. Also we have MOS transistors. So BJT, why we call BJT as bipolar junction transistor? Because bipolar. Here, the current flow is due to both majority as well as minority charge carriers. Both holes and electrons contribute to the flow of current. So it is bipolar as well as bijunction. We have seen in the previous diagram, there are two p-n junctions for a transistor. So it is bipolar bijunction transistor. And here in transistors, in BJT we have two types. One is NPN and one more is PNP transistor. Okay. So this is the transistor block and symbol representation. This is for NPN transistor. Earlier we have seen the construction, that is how between two N layers there will be a P material. In symbol we write the transistor symbol like this. Arrow mark, if it is going out, that is the symbol of an NPN transistor. If it is coming in, entering in, that is the symbol of an PNP transistor. The arrow mark indicates the conventional direction of current. Okay, so the arrow mark is going to be very important for both NPN when you write the symbol of a transistor. So this is how a transistor looks like. Okay, low power transistors and high power devices. So operation of NPN transistor. So this is the constructional diagram of NPN. NPN transistor. So this is emitter, the middle one is base and this one is collector, E, B, C. So in NPN transistor, the current is due to the movement of free electrons. Okay, the emitter base, this is emitter and this is base. So always for a transistor, when you bias the transistor, emitter base junction has to be forward biased, collector base junction has to be reverse biased. So emitter base, look at the supply what we have connected to emitter base junction. So in NPN transistor, emitter is N material, base is P material. So in order to forward bias emitter base junction, we have to connect emitter, that is N, forward bias. So N to negative and base, which is of P material, to positive. That is denoted as VEB. Okay, collector emitter base junction has to be forward bias. Similarly, reverse bias the collector base junction by connecting collector, that is N material, to positive terminal and base to negative. So when VEB is greater than the barrier potential, obviously when you give forward bias a PN junction, what happens? There will be a barrier or the depletion region which is created. So when you make more and more positive, what happens? The junction is forward biased, which causes the free electrons in the N-type material to flow towards the base region. And this constitutes the flow of current in the NPN transistor. As base is very lightly doped, only few electrons combine with the holes and constitute base current IB. So IB current will be very small compared to your IE and IC, emitter current and collector current. Thus most of the electrons will diffuse to the collector region and constitutes the collector current IC. So this is IC current, collector current. So always IE will be equal to IB plus IC. So when you add both base current and collector current, that will be equal to the emitter current. So similarly, you can analyze the operation of PNP transistor. So here emitter material is P, base is N, and collector material is P material. So in order to make emitter base junction forward bias and collector base junction reverse bias, connect emitter to positive, base to negative, which is denoted as VEB, or you can also call it as VBE. Similarly here, collector to negative and base to positive, you can call it as VCB, or generally we call it as VCC. So again here also IE will be equal to IB plus IC. Emitter current will be equal to collector current plus base current. And this collector current which is coming out will be the addition of both majority carriers as well as minority carriers. As I said, BJT is called as bipolar. Polarity is due to both majority and minority charge carriers. So current is due to both majority as well as minority charge carriers. And this is the flow of current in PNP transistor. So IC current will be usually in milliamperes, and whereas ICO, the minority carrier current, will be in nanoamperes. So transistor voltages in NPN PNP transistor, the similar diagram, the same diagram whatever we have discussed in previous slide, we are writing it in the form of a circuit. The same connections whatever we had done in the form of a circuit here. This is for NPN transistor and this is for PNP transistor, and this is VBE. Here we are denoting it as VB, and this is what is your VCC, which is between collector and emitter terminal. Similarly, this is the circuit of PNP transistor. So this is an important question for your exam. You also have to indicate the current directions, voltages, everything properly. The same transistor currents in PNP transistor. See here in this diagram, we have clearly given the current directions in case of PNP transistor. IE will be equal to IB plus IC. You can also apply a KCL here. You will get the equation as IE is equal to IB plus IC. So emitter current, which is the current entering the circuit here, IE. Which are the currents leaving the circuit, IB and IC. So sum of the currents entering the circuit should be equal to the sum of the currents leaving the circuit, leaving the node. So IE will be always equal to IB plus IC. So almost all the emitter current IE crosses the collector and only a small portion flow out of the base terminal. Okay. Also, we have an equation called IC is equal to alpha into IE. Alpha is the current gain, which we'll be discussing. Okay. So these are the equations derivation which is done in the class. So IE will be equal to IB plus IC. So IC will be alpha times of IE. So you can substitute equation 1 in equation 2, and if you simplify, you get back IC is equal to alpha divided by 1 minus alpha into IB, where alpha by 1 minus alpha can be called as beta. So IC will be equal to beta times of IB. Similarly, currents in NPN transistor, which is in the opposite direction. So same equations you will get. IE is equal to IB plus IC. IC is alpha times of IE. And since base is very lightly doped and very minimum current flow through the base terminal, we can usually in the calculations we do neglect the base current, which will be in microamps. Okay, so IC can be approximated to IE. Similar derivation here. So that is the basics of NPN and PNP transistor. As I said, alpha and beta are the current gains. So we have two terms here, one is alpha and one more is beta. So what is beta is? Beta is collector current to the base current. What is collector current here? Collector current is the output current. How do we usually calculate the gain? Gain is output by input, right? So here current amplification is output current divided by input current. Output current is IC current divided by input current is IB, the base current, which will give you the value beta. Similarly, alpha equations we have derived in class. So transistors can be connected in three different configurations: common base configuration, common emitter configuration, and common collector configuration. So in the next video, we'll discuss all the three configurations.